Thanks for coming. I know it's much tougher in summer to come to a presentation, but we have got a brilliant presenter tonight from UC Berkeley Extension, and I know he's going to inform us so much about Ethereum. But firstly, I wanted to introduce Suraj. Suraj is actually a patent attorney here at Shepherd Mullen. Really nice guy. And he's just going to say a few words. He's actually hosted the drinks tonight, so.
Thank you. Hi, everyone. My name is Suraj Hussain. I'm an intellectual property lawyer here at Shepherd Mullen. For those of you who don't know, Shepherd Mullen is a law firm with over 800 lawyers spread out in 16 offices worldwide. We have practice groups ranging from antitrust to taxation. We also have a number of industry-specific teams that focus on core niche technologies like blockchain and digital currency. So whether you're looking for advice on your next ICO or you want to file a patent application on your blockchain idea, we can certainly help. Tonight's event is on Ethereum development. You may be wondering why a law firm is sponsoring such an event. The answer is pretty simple. We're a technology-focused law firm, and we're constantly looking for ways to better service our clients. And Ethereum has shown tremendous promise, especially in the smart contract space. We look forward to embracing this technology and revolutionizing the practice of law. So thanks for being here, and I hope you enjoy the event.
Thanks so much. So now I'd like to introduce Pavan Katapali. He's actually going to do the presentation tonight, so I'm going to pass. Thank you.
Hey guys, thanks for coming by. I know it's a beautiful day and you came here, so I really appreciate your time. Let me just put this down right here. I didn't want to make any assumptions for today, so I'm going from the very basics. So you probably know a lot of these things, but I didn't want to make any assumptions. So first off, like after today, I guarantee that you'll be ready to start like coding on the Ethereum blockchain. What that is like you'll be ready to jump in to make an ERC20 contract, basically, which is a token. Like when people say tokens on the Ethereum network, they mean like an ERC20 contract. So you'll be ready to jump into that. So this will be you afterwards, after today, hopefully, right? Just like walking away, really cool. We'll start from the very basics. Oh yeah, well, about me. I taught Study the Blockchain, which is like a Solidity boot camp. So I just finished teaching that, and the students presented in front of Consensus Ventures, which was really cool. And I also teach at Berkeley Extension. I teach data analytics and web development there. Taught at Rutgers, General Assembly, Barnard. A long time ago, I had a TEDx talk. I had hair back then, so it's so weird to kind of see myself. Was CTO of a healthcare company, INR Tracker. And I'm speaking at Block World. It's a conference coming up in September. These are things I've taught. And first off, what is a database? What is a database? So a database is just a program that takes that takes in data. You can add data to it, and you can get data from it, right? That's what a database is. And it's kind of weird I'm talking about a database right now, but I mean, that's leading up to Ethereum, right? So you can add data to a database. You can get data from a database. And databases are programs. They run on your computer, right? They run on your computer. It's just a program like Microsoft Word. You have Microsoft Word. You double click on it. It's a program. It's running on a port on your computer. And that's what a database is. It's running on your computer, or a server, right? A server is basically a computer. And if this is too simple, stay with me, right? I'm sure you'll learn something soon. And then basically you have people, you have websites or apps that connect indirectly or directly to the database to add or get data, right? So that's what a database is. And like, there's like a viewpoint, maybe databases are complex. That's wrong, right? They're not complex. Databases are simple. If you've ever used Excel or a Google Sheet, right, you know how a database works. Right here we have 4 columns: ID, name, quantity, unit. We have basically things in your fridge, right? You have pickles, apples, pears, ice cream, et cetera, et cetera. And this is what a Google Sheet looks like, right? And this naming convention, fridge_foods, this is this is a name of the Google Sheet right here. And if I go to the next slide, this is what it would look like in a database table. Basically, this, right, see how ID, name, quantity, unit? It's basically the same thing. It's a little bit more complex if you go behind the scenes of how this database table was made, right? But it's basically the same thing. A database table is like a Google Sheet, right? A database is like a workbook, like an Excel workbook. And you have typical databases like MySQL, Postgres, MS SQL, Oracle, SQLite, MariaDB, Microsoft Access. Raise your hands if you've ever used one of these before. Wow, okay. A lot of people. And these are relational databases. I mean, there are non-relational databases like MongoDB and CouchDB, but if anything, I like to think that Ethereum is more related to like a typical database. Now, all those typical databases, MySQL, Postgres, Oracle, they're usually centralized databases. Usually. I mean, if you set them up in an interesting way, they could be decentralized, but they come kind of out of the box to be centralized. So right here, like if you imagine these yellow and red Legos, right, to be people and applications, these yellow and red Legos, and these blue Legos to be the database, right? This blue Lego thing in the middle is a database. It's a centralized database. And then you have people connecting and applications connecting to that database, right? It's centralized in one location, right here. So MySQL, PostgreSQL, it doesn't matter what program you're using. It's centralized. Now, decentralized databases are different, right? Which is what Ethereum is. Ethereum is a decentralized database. That's why I've been talking about databases. Ethereum is a decentralized database, and basically, the database is distributed. Like there are copies of the database around, right? So like if you imagine all these yellow and red things to be nodes, right? Ethereum nodes, which I'll go into exactly what an Ethereum node is. But these blue things, that's the database. And every single person has a copy of the database, right? It's distributed. It's decentralized. It's distributed and decentralized. Did I lose anyone? Questions on anything so far? Yeah.
Has all states of the database. So you're showing just one piece of the database, but it's the exact replica of the entire database.
Oh yeah, in this example, imagine the blue thing. The blue thing is the database. Yeah. Again, I guess it's not one-to-one with the other example. Otherwise, like you'd have like 6 blocks.
That's right.
What was it? You'd have you'd have 8 blocks for each person. Yeah. Good point. Yeah. Imagine each blue thing's at 8 blocks, right? It's basically a copy of the database that everyone has. Thanks for pointing that out. So I told you like this is the Ethereum database. You could also call it software, right? Because MySQL is software. Now, what is a network? What is a network? So if you just look at things from like a high perspective, it's just a bunch of things or people that are connected to each other in a certain way. So like if you had a bunch of people and they had a private Facebook group, right? That's a network right there. If you have a bunch of phones, they're connected together, and you could transfer calls from one phone to another, that's a network of phones. Or you could have a bunch of computers connected together that share data with one another, right? That's a network of computers. And Ethereum is a network of computers that hosts a shared database that runs special code. Right? Remember special code. Right? It's a network of computers that hosts a shared database that runs special code. Now, the shared database on Ethereum, on the Ethereum network of computers, right? It's decentralized. If you go back to this slide right here, right? It's decentralized. The blue thing, the blue Legos are decentral. It's a decentralized database, and the database itself, like we saw in the previous example, that that database had foods in a fridge, right? Now, the database in Ethereum has like transactions, and the transactions can be from person to person or from person to contract. Do you have a question? Yeah.
Clarification. Does this remain the same thing, but it's decentralized?
Yeah, same. They're basically the same thing. Yeah, that's a great question. Decentralized, distributed. I think it's the same thing. Yeah, yeah. As long as like they're copies of each other, right? They're exact copies of one another, and they communicate to each other when changes happen, and they all have those changes. And it's basically they're communicating the transactions, right? If I detect a new transaction, I'm going to communicate it to the rest of the nodes out there. Now let's dive a little bit deeper. Transactions between people. Raise your hand if you've sent Ethereum to someone or sent Bitcoin to someone. Okay, we have. Okay, go ahead. For is that Rafa?
Yes.
Rafa. So you sent what was it, Ethereum or Bitcoin to someone? It was Bitcoin. So to do that, what did you use, Rafa? Oh, sure, wallets. Yeah. So you used a wallet, right?
Yes.
And then, so when you did you send it or did you receive it? Send it.
I sent it.
You sent it. So to send it to that person, you had to get something from that person. What did you get? You get the address, right? The address. So you get that person's address, and you have an address yourself, right? So you have an address for your wallet, and then you find someone, and they have a wallet, and they have an address, and then you could send Ethereum to that person, right? Right, and that's how a transaction happens between people. You send Ether, and then you have an address, and they have an address. Yeah. Yeah, it's almost like PayPal, right? So it's like you have an email, you have a PayPal account, and then you have someone else has a PayPal account, and you ask them what their email is, right? Instead, you're asking what their address is in this case. And now transactions between people and contracts. Has anyone ever sent Ether to a contract? It's interesting. In the Ethereum network, there are things that's special code. Remember special code? The Ethereum is a network of computers that hosts a shared database, and these network of computers can also run special code. That special code is called a smart contract, and these smart contracts essentially have their own addresses. It's like code that have their own addresses, and you can actually send money, send Ether to a person that has an address, or to a contract that has an address, and the contract can ingest that money, right, and hold on to it, because it has an address, and also associate it with you. And we'll talk about that later. We'll get deeper into what that looks like. Transactions between people, one another, and transactions between people and contracts. Any questions so far? Yeah, so that's so interesting. That was when I was reading about Ethereum back in the day. I was like, can contracts talk to one another? They can talk to one another, but it's always a person kind of starting it. So like a contract isn't it's just code, and for code to work, you need to like run it, right? So you need to say run this function, right? So it's always a person running that function, right? So kind of, right? Kind of. Yeah, go ahead.
You use interchangeably with contracts the notion of an autonomous agent or an anonymous agent?
An anonymous.
That term at all?
Yeah, it's interesting. So the contract will have an address, and I'm not going too deep into this part, but to make an Ethereum address, like you don't even need to be online. It's just an algorithm, right? You just pick a secret, you feed it through the algorithm, you get your address. You don't even have to be online to make an Ethereum address. So in that way, it is kind of anonymous, right? Because you don't know who this person is or this contract for that matter. And there are lots of people that use the same Ethereum address for all their transactions. And there are people that generate a new Ethereum address for every transaction. So that way no one knows what their history is ever. So it depends. Depends on if you've always used the same Ethereum address, then it's not anonymous. If you're using a new Ethereum address, then it is anonymous in that way. Any other questions? Okay. So what's an Ethereum transaction? Like what's inside of it, right? So inside of an Ethereum transaction, it's basically like an object, that thing with a curly brackets, or a dictionary in Python. And basically there's like a different component, there's different things inside the object. There's a nonce, and if you're sending out one transaction, it's the nonce is a number. It's just like a number that's used once. And the nonce is 0, right? If there's only one transaction being sent out. If there's multiple transactions being sent out, then the nonce, the first one is 0, the second one is 1, the next one is 2. Then you have the gas price. Gas price is how much this transaction is going to cost, right? So if I'm sending money to Rafa, right, to do to check my ICO out or whatever, he's a lawyer, then I would set the gas price. Because my transaction is going to cost something. I'm not going to get into the mining part, but that money would go to the miners for verifying that the transaction is correct. And then there's a gas limit. The gas limit is the maximum amount I'm willing to spend on this transaction. The value, this is Ether. This is how much Ether I'm sending to Rafa, right? So this is the amount of Ether that I'm sending. And then data is if I'm sending money to a smart contract, or if I'm sending a transaction to a smart contract, the data would be like, what function am I running? Like, what function inside the contract? What code do I want to run in the smart contract? So this is what an Ethereum transaction looks like. Surprisingly, you don't even have to there are people who have launched ICOs, who have launched blockchain projects and never really even know these things, right? So these things it's more higher level, right? But just to give you an idea of what's happening behind the scenes. Go ahead.
The next level is that you are like giving out value and you request value.
Can you request value from someone? You can send value. You cannot request value. When you go to, I'm sure a lot of you have GitHub accounts. If you don't, it's not a big deal. It's just it's a website you sign up to. But the Ethereum GitHub page, there's a special section on the Ethereum GitHub page called EIPs. These are proposals for the Ethereum network. There's a new proposal. It's getting traction. It's to take subscription payments, right? If that passes, then yes, you can request Ether from someone, right? But right now you cannot. Someone can only send you Ether. That's it. You can't request it. But if that takes off, then it's in the beginning stages. But if it gets in the further stages, that EIP, then development will start on it. More, go ahead.
So what's typically in the data, and is that going to affect the gas price and gas limit? I mean, should you store a bunch of data in here, or should you store some of it somewhere else?
It's interesting. So if you're sending money to a contract or to someone else, the gas price will be pretty standard. I mean, it depends on the network capacity, right? If there's a lot of people hammering the network, then maybe the gas price will be a little bit higher. You can't store that much data in here, right? It's just it's a small object. So you can say what functions you want to run. You can pass in data, some arguments to your function. Now, but if you're trying to run a function, if you're trying to run a specific function in the smart contract, which we'll get into later on, let's say the function's massive, right? Or let's say the function. So one of my students made a smart contract that lets musicians ICO, right? So the smart contract itself has like a bunch of ICOs inside of it, and so when someone runs that function, it costs like $300 to run just to run that one transaction right there, because they're starting their own they're starting their own crowd sale, starting their own token essentially. But you could have one that just changes data a little bit, and it costs like 10 cents. So it really depends on what you're doing. Yeah, go ahead. Yeah, I mean, I can get into it later afterwards, but like I think Hyperledger is a cool project, just from like a technologist perspective. I don't really, yeah. I think so. I mean, like, I don't know if it's as decentralized as it should be, but I think it's cool in what they're doing, and I think their documentation is great. And IBM runs great cool events teaching you Hyperledger if you're interested in that. It's another blockchain. Now, did I? Oh, yeah, here we go.
I still have some more questions. The data part you were saying.
Mhm.
Let's say I'm running a function that uses some transaction, but it needs a lot of external data to actually go through the transaction.
That the external data doesn't matter because you're running a function, right? At the end of the day. So let's just say I'm like running a function that takes in a prime number, right? That takes in a prime number and returns a prime factorization of it. It's going to take a massive amount of computing power to kind of like generate, if it's a huge number, let's say 50 digits, 50 digit prime number. I'm going to get you the prime factorization of it. It's going to take a lot of work to do that, but like whatever it took you to do to get to that prime number, that's on you. That's on your computer. That's on your local computer, not on the Ethereum network.
Using this, I can pull data from other external sources just to do the computation.
Yeah, I mean, like essentially, like you have code, and you have arguments in that code, right? That code lives on the Ethereum blockchain, and then you can pass arguments to that code, and what it took you to get those argument values, like that's on your computer. It's not going to run on the Ethereum network, right? Go ahead.
So the gas limit is set by you.
Yeah, the gas limit set by you.
The gas price is determined on the network, and who else on the networks using the resource.
Mhm.
So if I set a gas limit and it doesn't clear at the gas price,
It'll fail. The transaction will fail.
Transaction will fail, and then does it iterate till it rings?
No, it'll just fail. It'll just fail. It'll just fail right now. And the error it'll give you will be like gas limit not high enough or something. Yeah, one more question. Go ahead.
When you calling the data when it is cool?
So it's actually, so if you imagine all these bullet points are keys inside of an object or properties inside of an object, and it's literally called the word data inside of it. Like that, it's just them. It's the Ethereum developers that created this object and just decided to name this key data. Inside of that data keyword, it's not the code, it's what function you want to run in the code. Yeah. All right, so Ethereum, it's a network of computers, right, that hosts that shared database that runs special code. Special code is smart contract. That special code that it runs is a smart contract, and anyone can anonymously create this code, right? Anyone can anonymously create this code. If you kind of imagine the Ethereum network as the Apple Store, right? As the Apple Store, not anyone can launch an app on the iPhone store. Not anyone can. You have to get approved. You have to pay money, and you have to be approved. Your app has to be approved, and you have to be approved. And also, that could be revoked at any time, right? If you don't follow their rules or whatever, or if you're copying someone's app verbatim, right, they might reject you. Not the case on the Ethereum network. You don't need anyone's permission to launch code onto it, which is insane, because there's about 15,000 plus Ethereum nodes around the world. So when you launch code on the Ethereum network, your code gets put onto every single node out there, right? So, and you don't need anyone's permission to do this. Anyone can do this, right? And you could do this anonymously also. Now, once you launch code onto this network, you can't change it ever. You can never change the code ever again, right? There are interesting architectural patterns that kind of let you get away from this, right? But essentially, the code can never change, right? The actual code can never change. The data in the code can change. The state of the code can change, but not the code itself. And that's where the trustworthiness kind of comes in. Now, anyone can see this code. It's public, kind of, for the most part. For the most part, kind of. And I say for the most part because it's actually, if you don't publish your smart contract, the bytecode is kind of easy to get to, right? The bytes, like when you take the code and you run it through the Ethereum program and it converts it to the EVM, converts it to bytecode zeros and ones, that's easy to get to. But the actual smart contract, they have to publish. You have to kind of publish it. And there are surprisingly huge companies that never publish their smart contract, and they're doing millions of dollars, right? Which is kind of scary because at any time, the developer could run a crazy function inside the code that says, give me all the money, right? So you always want, whenever you're using code that runs on the Ethereum network, you want to be able to see it, right? And then you also want to verify that it matches the bytecode. Go ahead.
So is that the difference between a public chain and a private chain? Is that what you're saying?
Interesting, a private chain. I've never really used private chains, but the Ethereum is very much a public chain, very much a public chain.
Well, I guess the question is, so when you're talking about the dApps on that public chain,
Mm-hmm.
so those companies have the ability not to publish their contract, but still have.
Yeah. It's just a matter of like me saying, like CryptoKitties. People for CryptoKitties, they published 3 of their smart contracts that are used. One of their smart contracts they haven't published, right? So I mean, the bytecode's out there. I'm sure you can figure it out if you tried really hard, but they're not publishing it. They're saying that that's where they're like the genetic algorithm of how the kitties breed with one another is kind of like copyrighted or whatever. Like that's where their juice is. Yeah.
My understanding was, at least initially, was that the entire blockchain could fit in memory for a person's laptop. Is that true? Is it still the case?
It's hard if you have gigabytes and gigabytes.
Exactly.
Yeah.
So, when at what stage will we can't fit it all in memory? What are the ramifications there? How important is it to have the whole blockchain?
So if you have a wallet on your phone, it doesn't have the entire Ethereum blockchain on your phone. It uses the developers, whoever made that wallet, they programmed it using services or oracles to basically kind of give it access to all of the transactions, like all of the data.
It is that the spirit of blockchain is the openness, so you have access to everything that's in the blockchain.
Yeah, I mean, like it's a hard balance there, right? And between openness and like having it all, right? It's like a hard balance between both, because on your phone you want the convenience on your phone, but you don't want to have like all those gigabytes kind of like stored on it. So it's up to developers to innovatively like program it in a way that is secure. And yeah, I'm gonna just jump into the next slide. Yeah, the special code, the smart contract, right? The special code is called the smart contract that all this network of computers are running. And the main languages are Serpent Viper and Solidity. Solidity is the main one. Solidity is the main one that has taken a lot of traction. There's a lot of documentation on it. And a lot of people are using Solidity to make ERC20 tokens and dApps on the Ethereum network. Now, anyone can run this. The code lives forever. And in most cases, the code is very trustworthy. And like I said, in most cases, it's very trustworthy, right? Because like the developer could publish code that says like, if I run this, then give me all the money that was sent inside of the contract. That's why you want the code published, and you want to verify that it is actually the code that is running on the dApp. Now, the code runs very slowly. Like the code's very slow, because like if you saw that decentralized picture of all those blue things around, like when you do an Ethereum transaction, when I send money to someone, that transaction needs to be broadcasted to every single node on the entire network. 15,000 plus nodes in the entire world have to have that transaction. When I publish code onto the Ethereum network, it goes on every single node out there. Every single node in the entire world, it goes out there. So it's slow, and it's also expensive to do that, right? It's not just one computer. It's like 15,000 plus computers that you're going to. And because of that, centralized databases are much, much faster and are significantly cheaper to basically add and get data from, to add data to. Now, so like, does that mean centralized is better? Does that mean centralized is better? So like, I remember there was a developer who came up to me and he's like, I want to make this like movie app on the blockchain, right? Like people could search for movies and I'll give them the best movie. And I was like, that makes no sense to put on the blockchain, right? Makes no sense. Like, you could put it on the blockchain. You could totally put it on the blockchain, but it's expensive. Like, every time someone wanted to add a new movie, it would cost money. Every time you wanted to update a rating, it would cost money, right? Whereas if you had it on a normal server, like, it would cost like minute like electricity costs. Go ahead. Sure. So it's like someone has to run these nodes, right? So like, let's say, is anyone mining here? Ah, cool. You're mining. You guys are mining Ethereum. A little bit. Yeah, I'm mining Ethereum too. So I mean, like, your setup is probably like, I mean, costs a decent amount of money to run one of these computers. You have graphic cards, right? It's like four grand probably to run one of these. And you make some money mining every day. So I make about $10 a day. My apartment complex is interesting, so I don't. Yeah, my electricity bill didn't go up, so I have no idea. I'm paying my electricity bill, but it's yeah, it doesn't. It hasn't. It went down somehow. Yeah. Yeah. But it's only no. I can't. I can't do that. Yeah. Yeah. So these nodes people have to run, right? These are random people running them, trying to make a buck on mining.
When Microsoft says that they support Ethereum for the provided API, does this mean that these 15,000 computers use Microsoft?
No, Microsoft isn't really doing anything. The Ethereum software is like public, it's open source, and although Microsoft, NVIDIA, Amazon, they're all miners. Like whenever they have like all these expensive GPUs, when they're not being used, they're mining, like guaranteed, right?
A few months ago, I read that the cost of mining essentially negates the profit of the whole.
The cost of mining. If you're in Washington State, electricity is so cheap, or in Canada, it's like so cheap.
So there are places where it's still profitable.
Yeah, and also you're also kind of betting on Ethereum going up, right? And you're also supporting the network by verifying transactions. So there are people who run full nodes that don't even care about the money.
Those systems that use trust say that they eliminate the cost of doing the mining, and that's why they're better.
Eliminate. It depends. Like, I'm not completely sold on proof of stake and stuff, but like I have to really look into it. Like, I'm not an expert on it. Like, I understand proof of work, but I'm not really an expert on proof of stake. So going off of that, what is an Ethereum node, right? You said 15,000 plus. Like, why not 20,000? Because people just like you and I, who are just trying to make a buck, right? Are running nodes. It's basically an Ethereum client. And they verify these transactions as being correct or not. Meaning, let's say I try to send 3 people in this room my 5 Ether, but all I have is 5 Ether, and I send it to you all at the same time, trying to trick you into giving me, I don't know, something, right? It'll fail. Like, 2 of the transactions are going to fail, right? And that's because of the miners. The miners are running software that verifies that these transactions are correct or not. And now, not every single client can run smart contract. That's special code. Not every single client can run it, because imagine a phone, right? We talked about that. A phone doesn't have that much space, so it can't even hold all the transactions. So if you can't hold all the transactions, you can't verify everything. So not everything is good for that. Now, 15K nodes, this is where they're distributed. So most of them are in America, right? So go America. And then China's right up there. I'm surprised it's only 1883. So I pulled this, I think, just yesterday. So this is up to date. I imagine this will probably go up to 16,000 by the end of the year. People are just like starting mining. Surprised about South America, though. Really surprised about South America. Go ahead.
How do you look this up?
I forget what site I got it from. If you just type in Ethereum nodes, number of Ethereum nodes in the world in Google, I'm sure this site will come up. Yeah, number of Ethereum nodes in the world. I'm sure this site and map will pop up. No problem. Yeah, so it's pretty cool. Like this network of computers, like your code is going all over the place. It's going in China. It's going in America. It's going to the United Kingdom, Germany. You got code. You got your code in Japan. It's really neat. Now, no one buys Ethereum. When people say they invested in Ethereum, that's correct. When I say I invested in Ethereum, that's correct. But I bought Ether. I bought Ether. Just like if I said, like I invested in Google, I didn't buy Google. I bought shares in Google, right? It just I guess grammar almost. But like when you say I invested in Ethereum, you bought Ether. Ether is the currency. Ethereum is the network of computers. Yeah. Now, over here, it says Ether is the fuel used to power the network. Ether is the fuel used to power the network. And so what does power the network mean? So Ether is used to basically pay for transaction fees. So if I'm sending money to one of you guys, right, sending Ethereum to one of you guys, I have to pay a transaction fee, right? And if I want to launch some of that special code, if I want to take special code, that's Solidity, that's smart contract, and I want to put it onto the Ethereum network, that costs money. That will cost money. If I want to put code onto the Ethereum network, it'll cost money. So like that Ether is used to pay for that. And then it's also used to call functions from the contract. So if let's say the code is launched, it's on the Ethereum network, right? And then someone wants to run a function from that smart contract, right? Then if that function changes data inside the smart contract, it changes the data, then it'll cost them money. Go ahead.
So, what prevents me
To create a node? Yeah, nothing stops you. Nothing stops you. I mean, you'd be helping the network though, right? So you like it.
I will have to join the network.
Yeah, I mean, there's very many YouTube videos on how to start mining. You just have to get GPUs to start it. I mean, when you're coding these applications, you don't have to worry about mining. Like, you don't even have to worry about it at all.
So this number 15,000 will change over time.
Certainly, yeah. If the price, let's say the price of Ethereum somehow goes to zero, right? Then that kind of ruins the network, right? Because then there's no incentive to keep mining, right? And matter of fact, the nodes would go down significantly at that point. But that's like probably the only danger of coding on the Ethereum network.
So what is the rationale for a miner to invest time?
You get money. You get rewarded for discovering blocks, for helping discover blocks, and verifying the network. Yeah, you're working together though. You end up working together with them. Yeah, I mean, I'm not going to get too deep into mining. We could talk about it later, but you end up working together and you share the profits, right? No one does it on their own, because then it's maybe in the beginning, but not now. So what is? Go ahead.
So I have a question about the last slide. What is the typical transaction fee? If I want to do a very small contract and you want to pay a really small amount, let's say 2 or 25 cents.
Depends on what.
Depends
on what you're doing. Depends on what you're doing. If you're trying to change a lot of data inside of a smart contract, then it'll cost you a lot of money.
It's a very trivial contract, very small amount of change. I just want to get some sense of, is this a ideal network for doing really small transactions and really small contracts?
You want to do small contracts. You don't want to put too much data on the blockchain.
So what would that cost?
It depends. Yeah, I don't know off the top of my head. I have a chart.
$1, $10, $100, $1,000. What is that? I mean,
to change like some data. It depends also, like depends on how hard the network's being hit also, right? So let's say for something very minor, changing a number, it could be less than $1. If you're just changing a number. We can talk about that. We can talk about that later, but like micropayments in terms of like 1 cent, 2 cents, probably wouldn't make sense. 5 or 50 cents, probably might not make sense right now. Yeah, maybe with Bitcoin on the Lightning Network, maybe it would. Oh yeah, go ahead. Absolutely, we're gonna get to that. I have a bunch of slides on that. Yeah, I promise. This is intro to Ethereum development. I have to go over like the basic fundamentals just to make sure that all of that kind of makes sense. But what is gas? Gas is the cost of invoking a contract, right? That gas limit, that gas cost, that gas price inside of the transaction, right? It's called gas. It's the amount of ether that your transaction kind of costs. And it depends on how much data in the smart contract you're changing. So why do we need gas? To prevent infinite loops, like to prevent like bad code. If someone wrote an infinite loop and there was no gas cost, then someone could run that function and take the network down. So that's the idea behind gas and proof of work, to prevent infinite loops. Now, is a smart contract smart? So we kind of talked about that. Can this contract have a transaction with another contract? Kind of, but only a person invoking a function in the smart contract could start that process from happening. So the contract is just code. If you've ever written code before, I mean, it's just words, right? And then you have a function, and you have to call that function. Smart contract, the same thing. It's just a word. They could have called it, contract. Matter of fact, it would probably have made more sense for them to call it like a class. I don't know why they didn't do that. Like a smart class. I don't know. Yeah, so essentially, if you remember back to the Google sheet of foods in the fridge, right? A smart contract is just a database table. It's a database table of that has data, and it also has code that can manipulate that data, right? So if you think of a Google sheet with data inside of it, some formulas, right, that can be ran to manipulate the code, or a database table that has, and you have some SQL queries that can manipulate that data inside the SQL table. That's all it is, essentially. It's code and data. Yeah, go ahead. How much data? Depends on how many variables you make, right? So you could have one variable, you could have probably 3 or 4 or 5. CryptoKitties has like a ton of variables. Like all those kitties are being stored inside that smart contract. Go ahead. It's super simple. You run the function, you get the data. No, it doesn't. To get data, costs nothing. Costs nothing to get data in the Ethereum network. It costs money to change the data though, because when you get data, you're not changing the network. When you change data, it has to be changed on every single computer, the entire network, and it has to be verified, right? So when you get data from a smart contract, you're not creating a transaction. That's not a transaction. You're just getting data. When you're changing data, then you're creating a transaction, and that has to be verified by the entire network of computers, and it has to go in the entire shared database on every single computer in the entire world. So free, that alludes to the next slide, right? Free to get data, expensive to change data, right? Free to get data, expensive to change data. Now into the coding part. Actually, how much time do we have left? 20 minutes? You know what? How about we spend 2 minutes just with each other, just go over what we just talked about the Ethereum network with your partners real quick for 2 minutes. Okay. Okay, all right. No problem. Cool. So the tech needed to code Ethereum dApps. Ganache. This is a common thing to use. Remix, MetaMask, Web3, and a coding editor. So it could be Sublime Text, that's what I use, or VS Code, or whatever. But Ganache is an entire Ethereum network that lives on your computer. It's downloadable. You can just go and download the program. And it's an entire Ethereum network that lives right on your computer. And you get 10 Ethereum accounts. An account is just an address, right, with a private key. So you get 10 accounts. and I believe you get like 100 ether. It's fake ether with each one, and it's your own Ethereum network. And you could click restart, and it resets the entire network. The interesting thing about it is because it's your own Ethereum network running on your own computer. Every transaction sits in one block, so it's not like 50 transactions in one block. It even mines itself for you if you set it. It's default set to mine for you.
So is this the default sandbox? This is how we use it?
Yeah, you need your own Ethereum network to kind of do that. There are newer tools if you're in the space, and Fura came out making things easier for a lot of developers. But but Ganache is still used by a lot of people. This is what Ganache looks like.
Typical machine you need for running this?
Computer.
I know.
Yeah.
But, does it need 100 gig of memory?
Oh, I see what you're saying. I have 16 gigabytes, and it runs slow sometimes, and I will only do this. It could be Windows. It can be Mac or Windows. It can be Mac or Windows. Yeah. I'm not sure about Linux. It probably would work. The GUI might not work. There's a command line tool that you can use. So this runs on port 7545. If you understand ports, basically a port is like a plug in the wall, right? So you have a plug in the wall. I can only stick one wire into it. So this runs on port 7545. You have about 4 tabs here. You have accounts, blocks, and transactions. Accounts shows you the 10 accounts that you have by default. And then transactions, these are all the transactions that you're running on your network, right? So what you're thinking is like, I'm not going to be sending this fake ether to anyone in my computer, so why do I even need this transactions tab? You need it because when you're launching your smart contract, when you're launching your code, right, it's basically a transaction. When you're launching your code, it's a transaction. When you call a function in your code that changes the smart contract code, the data, that's a transaction. So all these transactions add up, and you can see them all here. And then there's an address for every single transaction as well, right here. Remix. Now, Remix is interesting. It's basically a coding editor that lives in your browser. It's like Remix. If you just Google Remix coding editor, then you would see it. And basically, you connect this with your Ganache client. So there's a place you click, and you do port 7545. You put http://localhost 7545 in there, and it's connected to your local Ganache client. And then you can code smart contracts and deploy them onto your Ganache client right here. And it'll do all the conversion from taking the code and converting to bytecode and running it on the Ethereum network for you. It'll do all that. And this is what it looks like. You can even deploy to the live network, to the live Ethereum network from here also. You just have to choose it from the menu. And it's basically a coding editor. I mean, if you've ever used a coding editor, this is what it looks like. You have your files right here. .sol, that stands for Solidity. These are Solidity files, .sol. And you can click auto compile. So Java people, like you have to compile your code before you can run it. Just Solidity is the same deal. MetaMask. MetaMask is a Chrome extension that lets you kind of interact with your Ethereum network. And you kind of like need it. You kind of need it, and your users are going to need this. There's a new way of thinking with UI when dealing with MetaMask, because people aren't used to having some kind of weird pop-up demanding money from them when they're running a function, clicking a button on your site. So you gotta kind of have to think of things a little bit differently. This is what MetaMask looks like. It's a Chrome extension. It's free. Anyone can download it, right? So you have it almost looks like a basic wallet, right? This is what you have. This is account 1. You have an address right here. You have the number of ether you have. It automatically converts into dollars for you. This is when you sign up to MetaMask and you make an account on MetaMask, then you get the secret. You get the secret 12-word secret. Don't ever show this to anyone. This isn't real, by the way, right? This is fake. Like, it's not mine. But there have been instances where people have like accidentally shown their secret and their money's gone instantly. Like it's gone. But be very careful with this, right? Be very, very careful. Like write it down, you know, save it. Don't let anyone see it. Don't let your wife see it. You know, just be careful with all that. I'm just kidding. You should be fine with your wife seeing it. But over here on the right, you could select what network you're using. So you can click the main Ethereum network. That's the live network, right? If you're going to be surfing the web and you're using someone else's dApp, right? Then you want to be on the main Ethereum network. There's also test networks, and these are really cool because you can deploy for free on a live test network that your friends can use, right? And that's where you can debug things, and you could have your friends experience it, because you can't just be like, hey, everyone come to my house, you know, or my tiny studio, and try out my smart contract app. You could launch it on these test networks, and there's 3 of them, and then you could send your friends to that website and try out your smart app. Or you could click custom RPC. There's custom RPC, and right here, custom RPC, and then you could put in where Ganache is running, right? So http://localhost:7545, right? That's the default port that Ganache runs on. So you can just put that in, and now your MetaMask is connected to your local Ethereum client. And you just click on this network tab and change it whenever you want, right? And that's essentially all the hard stuff. That's it. Those 3 things, right? You download, you go to this website, done. You download this, double click on it, done. And then you install this Chrome extension, you click on network, you click on custom RPC, you put that port number in, and that's the setup right there. It's a very beginner setup, but it is a setup. And then there's Web3.js. Web3.js is a JavaScript library, and you include it in your HTML, right? Just like any JavaScript file, and basically it uses RPC, remote procedure call, to communicate to a smart contract, and it basically lets your website connect to your smart contract. It's almost like an API. But it uses RPC. So Solidity, again, it's the language used to write smart contracts. This is a smart contract right here. You got Pragma, Solidity, and oh man, I forgot what this even symbol is called. Caret, thank you. Caret right here. I know what it is. I know what it does. So you have this caret. What it does is it keeps going up. It takes your code. It takes your contract, which is lines 3 through 5, and it runs it on version 0.419, 0.42.2, 0.4.21. It keeps going up until it breaks, and then it stops at that version. That's what this caret does right here. It skips 0.5 for whatever reason, but yeah, that's what that caret does. It just keeps going up until the code breaks. And then this is the version of code that I'm running, 0.4.18. This is a version of Solidity that I'm using right here. This is contract. If you've ever written object-oriented code before, think of it as a class, right? This is the name of the class right here, sample. And then there's a file extension, .sol. That's Solidity. It's a Solidity file, right? So this is what a smart contract looks like. It's empty. It's completely pointless. I think it would still cost you money to deploy this, even though it's completely barren. It would still cost you a little bit of money to run this. Now this is, when I say data in your smart contract, this is data in your smart contract right here. This is data right here. You have your type of your variable right here. There are different types: string, bytes 32. There's UINT. There's int. There's a bunch of different data types. There's arrays. And then over here you have the visibility of your variable. So if I say there's 4 visibilities that you can have for your Solidity contract. There's public, there's private, there's external and internal. Public means anyone can see this. Anyone can grab this variable, like anyone. If I say private, then no one can grab this except for things inside of the contract, right? So like code inside the contract can use this, but no one else can. If I make it external, then it can only be accessed by someone outside of the contract if I make it external. If I make it internal, I can use it all over my contract. And then if I extend this contract, just like extending a class in Java or Python or whatever, if I extend this contract, then I could still use this variable if it's internal, right? But I can't use it externally. So there's 4 visibilities. People generally use, public and external a lot. And then, yeah, I don't see private that much, but it is important to understand and know. So this one right here is kind of completely pointless, but inside of an ERC20 contract, you have basically a string for the name of the token. So if you name this name and you gave your token a name, that's the beginning of an ERC20 contract. Now over here, this is a function to update state in your contract. So right here, the name of this function is called update val, and then there's one argument. And when you have arguments in Solidity, you type them. So I'm typing this as a string. So I can only take in a string. And it's typical to put underscores in front of your arguments in Solidity functions. You don't have to, but it's just like a coding standard that people do. Over here, I have external. So you can only call this function outside of this contract right here. So if someone calls this function, right, inside of that data attribute, that data property of the transaction would have update val, would have the name of this function, and it would have what they want to update this variable on line 4 to, right? It would have that. So let's say I passed in, this is not a sample contract, right? Is that going to be free or is that going to cost money? If I'm going to run this function, is this going to be free or is this going to cost money? It's going to cost money. Why? Because it's because I'm updating the data, right? I'm updating this data right here. I'm updating this data. So running this function is going to cost money because I'm updating this variable on line 4. If you're not updating anything, if you're not changing anything, it won't cost any money to run that function. So on line 4, in Solidity, when you make a variable public, you automatically get a getter function for it. So it's interesting. So what that means is inside of my HTML, my JavaScript, right, I can just call val. I can just call val and I'll get the value for val in it. That's what it means. I automatically get a getter function for val. Now, this is a little bit more complex, right? In Solidity, there are special data structures called mappings. And a mapping is basically it's a key value pair. It's a key value pair. So in this key value pair on line 4, I take an address and I'm mapping it to a value, right? I'm taking an address, I'm mapping it to a value. So remember, every wallet has an address. If you're communicating to a smart contract, you're communicating with the wallet, guaranteed. There's no other way of doing it, right? So there's only you have an address. So over here, I'm mapping the address to a value, and actually there's a tiny error here. This should be string. This should be string. I'm sorry about that. It should be string. And then this function over here on lines 6 through 8, it's doing almost the same thing as the previous function, right? It's almost doing the same thing, but what it's doing is it's taking that string, right? It's taking this argument and it's setting it equal to msg.sender. So inside of your contract, inside of this code, if I use msg.sender in my function, right, this is whoever's connecting to my function, their address. It's a global variable, msg.sender. So this is let's say, let's say, what's your name? Ethan. Ethan's calling this function add val, right? And Ethan's address this isn't his address, but 0xa, right? So over here, I'm putting 0xa in right here, and then whatever value passed in right here. And then that goes into the mapping on line 4. that goes into the mapping on line 4. So msg.sender is just the address of whoever's running the function. Questions on this? Yeah, go ahead.
Since this is a read function, it doesn't cost anything, right?
On line, if I call line 4 to get like the mapping information, that doesn't cost anything. But if I call lines 6 through 8, right? If I call this function, it's going to cost money because I'm adding to the mapping. I'm saying take that address, take whatever value you passed in, and connect them together and put them forever on the blockchain. Right here. Any other questions about this? Hey, go ahead.
You worry that someone could engage in like a mass usage against the entire system, and slow transactions down and actually invert the value of the actual.
If they're willing to spend the money. If they're willing to spend the money.
Well, take EOS, that's competitive, arguable. EOS just raised $4.2 billion. They could spend $1 billion trying to bring ETH down as a way to say EOS is better
for one day, maybe.
Might be enough.
I don't think so.
No?
Yeah, no. Because, like, we can talk about that later, but they're way behind in terms of, like, scatter. Like, MetaMask, there's MetaMask in Ethereum. There's scatter in EOS. It's not there yet. I mean, I've used it. It's not good. I mean, maybe in the future, but not right now. They have billions, maybe, right? Anyone who has billions can do something. All right, before this, like, so this mapping right here, right? This is essentially like for an ERC20 contract. There's a special mapping inside of an ERC20 contract called a balance. So it takes the address of the person and it maps it to a number. So that's when you buy an ERC20 token, it's like you're essentially, the number of tokens you have is inside of this mapping. There's a mapping and your address is mapped to how much you own inside of it. I mean, it's a little bit more complex than that, but that's essentially what it is. Now, there's not a lot I could have gone through, and I want to make sure I went over the fundamentals first. You can email me. I'll send you the slide deck. I'm also making a bunch of videos on smart contract development. I taught an entire class on it. If you just shoot me an email, I'll probably have the videos done by the end of the month. I'll send them over to you, and you can also ask me questions. I have a bunch of smart contracts. Yeah. So thanks for having me, guys. Yeah.